Hello everyone, very good morning. So today we will see how we can draw this kind of dynamic bar which represents certain quantity that changes dynamically over frame using OpenCV. So we'll not use any GUI library, simply OpenCV, and we can draw such kind of a dynamic bar representation to represent certain quantity which changes dynamically over time. So you see, for example, here. So let's get started. Yeah, to demonstrate, how we can achieve this with OpenCV. Today I'm taking an example of eye opening application. So here basically you're estimating the distance of, how much the eye is open. And this eye opening is represented by this dynamic bars which changes over time. So for this application, I have some data. So I have some frames which shows the eye of a person. So I have covered the face for the privacy reason. And for each of the frame, then I have corresponding measurement in CSV file. So for each frame, how much is the opening in millimeter for the left eye and for the right eye. So this is our data, and we are going to use this to show you this example of how we can achieve this kind of dynamically moving frame. So let's see how we can compute this and implement it OpenCV. So I have some slides for this. So let me open that to explain what we are going to do. So to plot this, functionality of dynamic bar, we just need to use one OpenCV function, and that is for drawing rectangle, cv2.rectangle, and we can achieve it. So it's a very simple function where it takes in images input, then it takes the starting point and the end point of the rectangle, the color and the thickness. Now, when the thickness is -1, the rectangle which will be drawn will be filled totally inside. And if it's not, then it will just represent the thickness of the border. So for our case, first we need to draw this empty rectangle to show the location of where this bar would be. And let's assume that we want a rectangle of width 60 and height 140 pixel. So we have some starting point x0 y0, and we know the height of the box, and this is our width. So we can simply draw it by using this width and height to get the end point, which is x0 plus width and y0 plus height. So in images, the 0 0 is on the left top corner, so when you go down it's increasing in y-axis, and when you go right it's increasing in x-axis. So first thing is you will draw this empty rectangular box with this for every frame. So this is very straightforward. Now assume for one frame, the eye opening is 6 millimeter, and you want to represent this in pixels so that you can fill in as much of this box. So how we are going to achieve it? So first of all, what we know that when the eye is totally open, this box will be completely filled. So it will be equal to the height of this box. So the maximum distance is equal to the height of this box. Now we want to find out how many pixels this 1 millimeter, one unit of this distance corresponds to. So simple math, that pixels per unit distance will be the box height, which is the total by the maximum distance. So for example, the height of this box is 140 pixels, and assume the maximum eye that can open is at a distance of 10 millimeter. So 140 by 10 is 14 pixels. So basically 1 millimeter represents 14 pixels. Okay, so now once you know this, that 1 millimeter represents 14 pixels, for any measurement of eye, 1 2 3 4 5 6, you can compute how many pixels it corresponds to in this box. So for instance, our height, of this box in height of this eye opening will be equal to eye opening distance into pixels per unit distance, which is simply 6 into 14, which is 84. Okay. So now we know, what is the height or the representation of this measurement in pixels, which we need to plot into this box. Okay. So how we are going to achieve it? First of all, we'll have our empty box, and in this we are going to, like, empty rectangle, and in this we are going to draw another rectangle, but that rectangle will be filled in. Okay, and this rectangle will represent this eye opening distance in pixel. So the height of this rectangle is going to be 84 pixels that we computed just now. And so we need to draw another rectangle from here to here, which has a height of 84 pixels. And how we can do it? So we know that for drawing a rectangle, we need the starting point, we need the ending point. Now for this, we don't know the starting point, so we need to compute the starting point with respect to this. And we need this x and yn, like x and y, x new y new. So if you see, if we know this point, because we know it x0 y0, we can simply compute this by adding to the y this distance. Now we need to compute this, how much is this distance, and it's pretty, again, very simple math, that we know the total height, we know the height of this box, and we can get the starting, we can get this distance by h minus ih, which will be here 140 minus 84. So now once we know this distance, then getting this point is very straightforward. So the x-axis is not changing, the x point is same, so xn is equal to x0, but the y is changing. So we are going down, means the value of y is increasing, because image starts at the top, bottom, oh sorry, top left. So your yn is simply going to be y0 plus this distance, which is h minus ih, and which is going to be y0 plus 140 minus 84, which is y0 plus 56. So now when you know this distance, you get the starting point. You know the width is same as the previous rectangle. The height of this rectangle we just computed. So the end point is simply going to be x1 sorry, endpoint will be x1 xn plus width, and then yn plus this height, and that's all. And you just pass the thickness equal to -1 with this parameters, and you can get this filled in box. So that is it. So we have to just draw two rectangles, one empty and one representing one filled rectangle, which represents how much distance the eye is open in that frame. And in order to know that in pixels, you simply multiply the distance into the pixels per unit distance, and you get this height. And then you compute the starting point by adding just this remaining height from the original box with the new filled in box, and then that's it, you get it. Okay, so this is the idea, and you can maybe implement this logic for any other applications that you are trying to do. I hope you got the idea of how we are getting these points, and then we can see directly in code how we are doing it. So this is my code editor. If I zoom in a bit more, let's see, and also I'll share the code in the GitHub. So I'm just importing some libraries. I am reading the location of the frame. I'm reading the location of my CSV, which has the eye opening distance over frames, and then I'm also saving the plots with this drawn on dynamic bars. So I'll simply first do all this imports and path initialization, and then I'm reading this data file. I'm creating this destination directory if it's not there. I'm reading the total number of frames, and then I'm getting image, So here I'm also saving a video along with the frames. So I need to get the dimension of the image to define my video writer. Then here I'm defining the rectangular box width and height, which I'll be using. And then here I'm defining the starting point of the left and the right eye. So if you see, starting point of this and this, because we need to draw, just now we saw we need to draw this empty rectangle first, and we know the width and height, so we just define the starting point, and by adding the width and height we can get the end point and we can draw it. So this is just some variables. So for me, the image, if I just draw the image dot shape, it's 1301 is the height, 1600 is the width. So based on that, I have chosen my starting and end point because I wanted to draw it here. Based on wherever you want to draw it, you can choose your starting point, and then you can use this formula to compute the uh, draw it at the specific location. Now I'm defining the video writer, uh, and this is my video name, video writer. And then this is the helper function to get the number of pixels corresponding to per unit of measurement. So this one, what how what is the number of pixels corresponding to 1 millimeter or any other metric that you use. So basically, as I said, I'm just getting the left eye opening distance, right eye opening distance, and then I'm getting those max values, max and min values, and then in order to get this, I'm dividing maximum distance by the maximum eye opening of the left eye and the right eye. So 140 pixels, suppose it was 10, as I showed, and then it will simply return, how many pixels one unit corresponds to. And this is a helper function to draw the bounding box. So you just need to pass the starting point and the rectangle dimension, and it will compute the endpoint by adding the width and height of the bounding box. And then I'm just calling this function to get, so let's run this. Let's run it here. Okay, now you see, let me see what is my, you know, per pixel. Yeah, so you can see for the left eye, 1 millimeter width corresponds to 10.6 pixel. For the right eye, 1 millimeter corresponds to 9.94 pixels. Okay, then it's again, I'm starting the loop over all my frames. So here I'm reading alternate frames, and I'm reading the frames from the frame folder. I'm reading the image. So first of all, if you see, I'm drawing these empty boxes, and then I'm writing in some text which I need to present. So these are the text, and these are the empty box. And then I'm seeing, if the signal is valid. So basically, it's another way to represent. So if the signal is not valid, if there is some error or the eye is not visible, then we can represent it by, drawing red box. So if you see, if the signal is valid, we have the blue box. If the signal is not valid, we can draw the red box. That's why I'm just having this flag. But what you do, for every frame, you get the left eye opening distance. Then you compute what is the height of this rectangle by multiplying this distance into, per pixels per unit millimeter. And then you cannot cross the height of the box. So this is just a check to see that the maximum height of the box would be the height of the box that we have defined. And then we have the starting point of the new box. So which is x point is same, and the y point is basically the starting point of the original box of the y, plus h minus ih that we just computed here, this one. So it's basically, yeah, y0 and then h minus eh. Okay, so this is pretty straightforward. And then the dimension width will be same as the width of the original rectangle, and the height will be the new computed height. So the width is same and the height is a new IH. So that's what it is. And then once we have this, then we call in the draw bounding box. And for this, if you see, for the empty box, we gave the thickness as 3. And for this distance box where we want to show the filled in, we gave a distance of -1. And again, if the signal was not valid, then I'm drawing it with the red color box. And the same thing we repeat it for the right eye. And then once we have the box drawn in, then we give a name to the image. We write in the destination folder, and we also write to the video writer, and we repeat it for loop over all the frames. And then at the end, we release the writer, and that's it. So let me run this code. Yeah, so it's running. Say it takes around a minute. There's so many frames, and we can also see, how this frames looks like with the plot. So if you see, yeah, if you see, for every frame, how the distance is changing on the top right. So you see the right eye is closed, so it's smaller distance, and the left eye is a bit wider than the right eye. So yeah, it makes sense. And as I move forward, you can see how this box varies over time. Okay, I think, okay, the code is still running. So meanwhile, yeah, it's being saved here, so not a problem. So you see both eyes are closed, and left eye is little bit open, so, and right eye is totally closed, so it's like this. And then the eye opens up. Okay, so I hope you get this. Just a minute. So let me see, still some 10-11 seconds. Yep, and we can see the video which it is created. Okay. And you can use this for, any other quantity or application that you want to measure. Okay, I think, yeah, it's done now. Finished generating video. We can see the video here. And yeah, that's your video for you. And it's a very interesting way to represent this kind of dynamic quantities through this. It gives a wow factor. And yeah, so that is it. I think you learned something, and I hope this was helpful for you. I will share this script and also this some demo frames and that CSV so that you can also try it out and use it in your projects. So thank you so much for sticking by. I'll attach all the link in the description. And till then, take care, keep learning, and keep exploring neurons. Bye.